Welcome back. We want to start the first intuition tutorial for convolutional neural network. So the first thing that we want to understand is what are the layers that we have in convolutional neural network. So the first layer is actually convolutional layer. And the first thing that you need to understand, and it's very, very important, is image filter or kernel. So these are the words that could be used interchangeably with together. In this course, I typically use filter, but you can use kernel or feature map as well. But what is this filter? So most of you have used your phone or computer before for playing around with images and trying different filters on them, right? For example, blur filter is one of the most famous ones, and you may use that before. For example, putting blur filter on this picture and this image, and the result will be something like this. But what are these filters? These filters in computer are actually a small matrix that is used to apply an operation on an image with the goal of detecting specific features or pattern in the image. So for example, let's say if we apply this matrix, this 3x3 matrix on an image, we can blur it a little bit. So the filters are typically 3x3 matrices. It doesn't have to be 3x3. You can use it could be, for example, 5x5 or other sizes, but typically most of the time the filter that we use is 3x3 matrices. So this is what filter is. So filter, again, let's review it, is a matrix that we use in order to apply an operation on an image. But how we can apply that operation actually, how we can apply a filter like this on an image. So let's go a little bit deep into that part. Let's say we have an image like this. So you may say in the previous tutorial, you said the values of each pixel is something between 0 and 255. Why we have only 0 and 1? And that's because we normalize the pixel values to the range of 0 and 1. Let's imagine that we have a, for example, black and white image, and all the numbers are are something 0 or 1, something like this. So this is just a hypothetical thing that we want to consider. So this is our image with these values, and we want to apply a filter on that. So, and this is our filter that we want to apply it on this image, right? So how we can do that, how we can apply this filter, is starting from top left side of this image, this part, and multiply each of these elements of this filter, each of the values, 0, 1, 0, and so on, element by element to this part of our image. For example, we say 0 multiplied by 0 will be 0, 1 multiplied by 1 will be 1, 0 by 0 will be 0, and so on. 1 by 1 will be 1. So we are actually multiplying each one of these values by the value that we have on our image here. So we are actually putting this filter on this side of the image and this part of the image and multiplying each value element by element. And what we have at the end is summing up all these numbers. For example, here we have 1, 1, 1. So the summation will be 3. So we sum them up and we put them here as the first value of our filtered image. So imagine that this is our filtered image. So again, let's review that. We start from here. We put our 3x3 filter on the top left side of our image, and we multiply each element by the other elements related to that part. So for example, 0 by 0, 1 by 1, 0 by 0, and so on. And it will create something like this, and then we will sum up all the numbers together, and the result will be here. So we do the exact same process do the same process across the entire image. For example, we do it like this. We go one stride to the left, to the right, and then do the same thing with multiplying the filter again to this part. For example, we say 0 by 1 is 0, 1 by 0 is 0, 0 by 1 is 0, and so on. And you can see that at the end, the summation of all these multiplication will be 0 again. So we put 0 here. So this stride length is actually very important for us. So remember this term, stride length, is actually the length or size that we want to jump between the across our image. So for example, if the stride length is 1, we only shift our filter on our image one time. So by one values like this. But if it's 2, for example, instead of starting from here, the next time we start from here, this part. But let's imagine that the stride length is right now is 1, and let's continue what we have started. So we started from here, then with a stride length of 1, we started from here, and this is our next value, and then we continue this element by element until we finish our image, filtered image actually. So the final filtered image, or what we call it is a feature map, is something like this. If we apply the 3x3, our 3x3 filter in our image, we have something like this. So imagine that we are not just applying one filter, we are applying several filters on our image. And at the end, we have several feature maps as well based on number of filters that we apply. But the final feature map is actually a 5x5 image, which is the result of applying our 3x3 filter to our original image, which was 7x7. So in this filtering process, we actually get rid of unnecessary pixel and we create something like this. But we actually kept the important ones. So this is called convolutional operation. By applying the filters on our image and creating feature maps based on those filters, we are actually passing our image through a convolutional operation. And there is a rule of thumb, for calculating the feature map size. And it could be calculated based on the size of the original image. That is, for example, 7. So it's 7x7, we just put 7 here. And the size of the filter, that for example here is 3, so 7 minus 3. So if we divide this by the stride size, if you remember the stride size I showed you in the previous slide, it was 1. So we put 1 here, so 7 minus 3 divided by 1 plus 1, it will give us the final feature map size, that is 5x5. So you can use this feature map rule of thumb formula in order to calculate the final size of your feature map. There's another important step in a convolutional operation that I want to mention here, and that's padding. So what is padding? Padding is actually adding additional pixel on each side of our image. So we can increase the chance of some pixels being chosen for being in the final feature map. What do I mean? So for example, if we put our filter size box, if we put our box here in this area, look at my the cursor. So in this area, if it puts the filter, this pixel has only one chance to be in the feature map, right? But for example, this one has two chances. First here, if we put the stride 1, so the other filter map box will be here. So this will have another chance. For example, this 0 has 3 chances because this is 1. The next one is here, and the last one that's considered this one is when we are going down, when we are going here. So this has 3 chances. So if we want to give somehow increase the chance of these pixels in these areas, and also there's other reason for doing padding, and it's having the same spatial dimension of the feature map compared to the image. We want, for example, our feature map to be in the same dimension as our image. So that's why we are adding padding. So what is this padding? So this padding is actually, as I mentioned, is additional pixels. That's the value of these pixels are actually, all of them are 0. So we are adding padding around our image. We are adding additional pixels on the edge of our, on all sides of our image like this. And then we start applying the filter, our 3x3 filter, again, just like what we discussed before, again, starting from here, then starting from here, and so on. So the results will be actually increasing the size of our feature map, same as our original, equal to our original image. So we actually have this kind of feature map. So this feature map is not 5x5 anymore, and it is 7x7. So this new feature map that has 7x7 size, 7 widths, 7 heights, the feature map size will actually, this is the final formula for calculating the feature map size, including the padding number. So the value of the padding. So we are saying the size of our original image, for example, here is 7, the size of, minus the size of the filter, that is 3 here, plus 2 times of size of padding. So for example, here the padding size is 1 because we only add 1 layer of zeros around our image. But for example, you can have 2 layers of padding. So it will be 2 multiplied by 2. But here it's 1. So let's see how it will change. So 7 minus 3 plus 2 times 1. So it will be actually 8. It will be 6. And divided by this right, that is 1. So 6 plus 1, it will be 7 again. So the feature map size will be 7x7. That is actually equal to the original size of our image. So this is the final formula in order to calculate the feature map size. And we will use this formula actually in our coding as well. I will show you how when we want to calculate some of the inputs and outputs of the convolutional layer. So that was it for a convolutional layer part. Before we close this tutorial, I want to show you something also interesting about the image filters that's maybe interesting for you. So there are a couple of other websites as well that show you the playground of how you playing around with filters and images. But I like this one that I want to show you, this website. I put the link for you in the resource button, so you can just click on it and it will open up this website for you. And also this is the original website, so you can just type down the address of the website and this will pop up. So this is a image convolution playground in GitHub that you can actually upload your own image or use the default images and apply different kernels or filters on these images. Now you can see that the filters are actually numbers, as I mentioned. And for example, there's a 3x3 filter. As I mentioned, typically we are using 3x3 filters. And then you can actually, you can create randomized numbers in this filter, or you can even change the numbers in this filter. For example, by clicking on here, I can change this from -1 to, for example, 2. You can see that how, if I change this to 2, how it affects on the final picture. So you can also increase the pixel resolution by increasing the pixel size, the number of pixels of this image. You can see that we have high resolution right now. And you can do some customized filtering. For example, you want to do blurring, box blur. So for example, this is a filter for box blur, see? Or you want to, for example, do some Gaussian blur like this. This is the filter that you need to apply in this image to have the output like this. Or you can just play around with all these customized filter, or you can do it randomized. Not all the filters can work for you. For example, let's do some randomized. For example, this one will give us nothing. But let's do some other randomized. You see, this one, for example, is working. This randomized filter will actually give us something like this. And as I mentioned, you can even change all these numbers one by one here by giving it the number that you like. And you can also upload your image and play around with it, and you can understand better how actually filters working. So this is the exact same process that I mentioned in the beginning, that's about the filters and how different filters will be applied and will do some actually work on our image to give us the outputs, for example, like this. You can just play around with this GitHub playground, and in the next tutorial we are actually going after understanding pooling layers. So that will be very, very interesting. So until then, keep exercising and enjoy using this playground.